So due to demand, I will be doing question number 10.3 of exercise 3.3. Okay, so it is exercise 3.3, question number 10.3. Okay, clear? So now it says, the question starts with, express the following matrices as the sum of symmetric matrix and skew symmetric matrix. Okay, first thing we should know that how any matrix A is expressed as a symmetric matrix and skew symmetric matrix. We have discussed in class that any square matrix A can be expressed as the sum of symmetric and skew symmetric matrix. And how is that given by? It is given by A is equal to half of A plus A transpose, and we have already discussed in class that A plus A transpose gives you the symmetric matrix plus half of A minus A transpose. So this is the way we express any matrix as a sum of symmetric matrix and skew symmetric matrix. So you look at here, if you just look at in here, it is half A transpose, half A minus half A transpose. So minus half A and half A transpose goes away, right? So what remains? Half A plus half A, and half A plus half A is what? A. So it's just the same thing. Just because I have to express it in terms of symmetric and skew symmetric, I write it like this. Understood? So now in our question, what is A? A is given by 3, 3, minus 1, minus 2, minus 2, 1, minus 4, minus 5, 2. This is our A, right? So related to that, can I find A transpose equal to how much? So A transpose will be equal to, this row becomes column 3, 3 minus 1. This row becomes column minus 2, 1. This third row becomes column 3, minus 4, minus 5, 2. Clear? Okay. Now we have to find the symmetric matrix, and symmetric matrix is given by A plus A transpose. So let us find A plus A transpose. Just add them. How much you get? 3 plus 3 is 6. 3 minus 2 is 1. Minus 1 minus 4 is minus 5. Minus 2 plus 3 is 1. Minus 2 minus 2 is minus 4. I am just adding the numbers 1 and minus 5 is minus 4. Corresponding numbers I am adding. Minus 4 minus 1 is your minus 5. Minus 5 plus 1 is your minus 4. And 2 plus 2 is 4. You see, this one is a symmetric matrix. How can I say that this one is a symmetric matrix? You see, this A12, this one is equal to A21. A12 is equal to A21. A13 is equal to A31. A23 is equal to A32. Understood? These corresponding elements are equal. This one, this one, this one, this one, this one, this one. I don't care about the diagonal elements. So this is what? A symmetric matrix. Now let us find the skew symmetric one. So skew symmetric one is what? A minus A transpose. And that is given by what? This minus this. So 3 minus 3 is 0. 3 minus of minus 2. So that is plus 2. So 3 plus 2 is 5. Minus 1 minus of minus 4. That is minus 1 plus 4. That is 3. Minus 2 minus 3. That is minus 5. Minus 2 minus of minus 2. That is minus 2 plus 2. That is 0. 1 minus of minus 5. That is 6. Minus 4. And this one becomes what? So what we have in here? Minus 4 minus of minus 1. That is minus 4 plus 1. So that is how much? Minus 3. Minus 5 minus 1. So that is how much? Minus 6. And 2 minus 2 is 0. Clear? So look at here, in here for skew symmetric matrix all the diagonal elements are 0 and this corresponding elements 5, if it is 5 this one is minus 5. So A12 is equal to minus of A21, A13 is equal to minus of A31, A23 is equal to minus of A32. So it satisfies the condition of skew symmetric matrix, therefore this one is a skew symmetric matrix. So our answer will be what? Therefore A, which is the matrix given, it is expressed as half of 6 1 minus 5, 1 minus 4 minus 4, minus 5 minus 4 4, plus half of 0 5 3 minus 5 0 6 minus 3 minus 6 0. Understood? So this is our answer. This is how you express any square matrix as a sum of symmetric matrix and skew symmetric matrix.